So we are going to discuss the topic beamforming. Okay, so it is coming under the Mimo. Okay, so what are the subtopics we are discussing today? Smart antenna, then beamforming, types of beamforming. So what are the different types of beamforming? So one category is analog beamforming and digital feed beamforming, and the other category is, this is the first subdivision of beamforming, and the second category is conventional array, and second one is the adaptive beamforming. Okay. So then third one is the transmitter and the receiver beamforming. And what are the methods used to implement beamforming? That is the last topic. So we are going to use some techniques to implement beamforming. One is the explicit beamforming, and another one is the implicit beamforming. So these are all the topics we are going to discuss today. Okay. So before going to the topic, so we will get into smart antenna. So the smart antenna is one type of multiple antenna technique. So what do you mean by multiple antenna technique? Suppose if any system uses multiple antennas, either a transmitter or receiver or at both sides, that technique is called multiple antenna technique. So under multiple antenna technique, there are two types. One is Mimo and another one is the smart antenna. So already we have discussed Mimo. What are the advantages of Mimo? So Mimo, why we are going for multiple input, multiple output scheme? MIMO means multiple antennas at the transmitter and multiple antennas at the receiver. So what is the need of Mimo? For high signal range, these are all some of the benefits of Mimo. High signal range, high capacity, then high data rate. Then reduced interferences. So these are all the benefits of Mimo. For these reasons, we are going for Mimo. So another one subtopic in multiple antenna is smart antenna. So what do you mean by smart antenna? It also uses multiple antennas. Okay, so it is called as adaptive antenna. Smart antenna is nothing but adaptive antenna. So adaptive antenna means it consists of array of antenna elements. Not only a single antenna, it uses multiple antennas. That is array of antenna elements. It uses array of antenna elements with some smart signal processing scheme. Okay, so array of antenna elements plus smart signal processing scheme is called smart antenna. Okay, it's an adaptive antenna. So what is the function of smart antenna? How it differ from conventional antenna? So conventional antenna, it spread the signal in all directions. But smart antenna means towards the target, it transmitted signal. Okay, so it's a directional antenna. Smart antenna is a directional antenna. Normally at the transmitter side, we are using some conventional antenna. It transmits or it radiates the signal in all directions. So how it becomes smart? Okay, so using some signal processing technique. So using the signal processing technique, it first identifies the location of the target, where the target is available. So that location information is collected from the receiver. So based on the location, the antenna beam is tilted towards the target direction. That is, it radiates maximum power towards the direction of the target. So the intended user or the desired user can get more power compared to the interference user. So that is the function of smart antenna. So it's adaptive antenna. It consists of array of antenna elements with some smart signal processing technique. So this signal processing first estimate the location of the target. After estimation, it transmit the it send more power to the desired direction. So that is about smart antenna. So how we are relating this beamforming with smart antenna? The smart signal processing technique present in smart antenna is called as beamforming. Okay, so what do you mean by beamforming? Beamforming is a signal processing technique applied in smart antenna. Okay, the another name of beamforming is called as spatial filtering. So why it is called as filter? So because it allows the signal only towards the target and it rejects all other interferences. So that the name spatial filtering. So it's a signal processing technique in smart antenna. So this beamforming you can apply either at the transmitter side or receiver side or both or at both the sides. Okay. So using beamforming, what we are doing, so there is a direct connection between transmitter and receiver. Okay. So this beamforming transmit the signal directly to the receiver. So we can get some direct connection between the transmitter and receiver. Because of this direct connection, what about the communication? The communication is faster and we will be getting stronger communication between the transmitter and receiver. So that is the main aim of beamforming. Okay. So how we can implement beamforming? So it consists of array of antenna elements. So we have to combine the antenna elements in such a way that we should have more power should be transmitted towards the receiver target. Okay. Then other users should get less power. So more power should be transmitted to the target or that is your target user. For other users should get minimum power. So other users are called as interference. So other users should get minimum power. So minimum power is transmitted to interfering users. So this is about the principle of beamforming. How we can implement beamforming? So this is one example of beamforming. So here for this example, beamforming is applied at the transmitter side. So this is about the transmitter. It consists of more number of antenna elements. Okay. So this is about the target user and this is about the interfering user. So the transmitter should communicate only to the target user. Interfering user should not get any power from the transmitter. That is our aim. So all the antennas, so what we are doing at the transmitter side, the transmitter transmit the same information over n number of antennas. So all the antenna signals are combined at the transmitter side. So we can get all the antenna signals are combined. So we can get some high gain radiation pattern. That high gain radiation pattern is tilted towards the direction of the target. Okay. So this tilting process is done by beamforming. Okay. So we are doing this tilting process by means of beamforming. So what we are doing, all the antenna can produce some amount of gain. Okay, all the gains we are combining at the transmitter side. So we can get one high gain radiation pattern. That radiation pattern is tilted towards the target user. So the interfering user doesn't get any radiation from antenna transmitter. So this is about the function of beamforming. So it's a directional pattern. So beamforming is used to produce the directional pattern from transmitter to receiver. Okay, so this is about the simple example of transmitter beamforming. So write down the definition of beamforming. So beamforming, the another name is called spatial filtering. It is one type of signal processing technique. Note down the definition. It's a signal processing technique used for directional signal transmission and reception. It uses array of antenna elements and antenna elements are combined in such a way that signals at particular angles experiences constructive interference and while other experiences destructive interference. Okay, so signals at particular angles experiences constructive interference and signal other angles experiences destructive interference. What is the difference between constructive and destructive? Okay, constructive. There are two types of signal combining. One is the constructive and another one is the destructive. So constructive signal combining produces high gain. Destructive signal combining produces low gain. So this is the difference between constructive and destructive. So here we are combining all the antenna element signals. Suppose if you are combining antenna element signals in a constructive manner, you will be getting high gain. If you are combining in a destructive manner, you will be getting low gain. So what are the antenna elements we have to combine in a constructive manner? Only towards the target. What are the antenna elements transmitting towards the target? That only we have to, that signal only constructively added. So the antenna elements are towards the interference, that signal should be destructively added. So that is the principle. So towards the target, we have to apply constructive. Then towards the interference, we have to use destructive. Okay. So how we can add constructive? So here I am taking two signals. So now these two signals you see here. So both these signals are at positive half cycle at the same time. Both these signals negative half cycles are at the same time. If you are adding both these signals, what we can get? So you will be getting high positive half cycle and more voltage at the negative half cycle. So this is about constructive. So towards the target, what are the elements are there? All those elements are constructively added. Then destructive means what is happened? So this is about the first signal. Another one antenna signal is looking like this. Suppose if you are adding two signals, what about the resultant signal? So one signal positive half cycle time period, the other signal negative half cycle is there. So suppose if you are adding these two signal, you will be getting a null. Okay. So towards the target constructive and towards the interference null, destructive. So this is about the principle of beamforming. Okay. So we are combining the antenna elements in such a way that for a particular direction we can get constructive interference and particular other direction we will be getting the destructive interference. So this principle is applied in beamforming technique. Okay. So everything has happened in a adaptive manner. Okay. So because suppose your target may be a fixed target or mobile target. Suppose if the target is a mobile target, the beam should be rotated. Okay. The beam should be adaptive. So beamformers always track the target. Based on the target location, the beam is formed towards the target. So that is the principle of beamforming. So now we will go to the types of beamforming. So first category is analog beamforming and digital beamforming. So first category is analog and digital. So what is the difference between analog and digital? So both are doing at the digital baseband. What do you mean by digital baseband? So normally we are applying digital communication in wireless. Okay. So what about our information? Whatever may be the physical quantity, it is converted into digital. It is in the form of zeros and ones. So baseband means all the information should be converted into the constellation points. Suppose if you are using a BPSK. So what are the constellation points? 0 means it is represented by -1. 1 means it is represented by +1. So whatever may be the digital information, it should be converted into these points, -1 and +1. Suppose if you are using a QPSK. So what are the different constellation points? 1 plus J1. This is one constellation point. Then 1 minus J1. Okay, this is another one constellation point. Then -1 plus J1. minus 1 minus j1. So we will be getting 4 constellation points corresponding to 4 symbols. 0, 0, this is the constellation point. This is about 0, 1. This is about 1, 0. This is about 1, 1. So in this way, first we have to convert our information. So that is that constellation points are called as digital baseband. Okay. So both are doing at the digital baseband category. So now the difference is here only one information is transmitted. So that information is passed through the array of antennas. Okay. So we are applying some phase shifter. So every antenna element there is a separate phase shifter is there. After phase shifting, the information is transmitted over the antenna. So this is the principle of analog beamforming. Okay. So what we are doing, we have the array of antenna elements. Okay. More than one antenna element means that is called array of antenna elements, antenna array. All the antenna elements, we are transmitting only one signal. That signal undergoes different phase shift. Okay, so that different phase shifted signal is transmitted over every antenna. So this is the principle of analog beamforming. Here, whatever may be the amplitude variation, phase variation, everything is done at the analog level. Okay, so but digital baseband, so we are transmitting different information over the antenna. Here also we are using the multiple antennas or our antenna array. Every antenna element transmits different information. So that is the basic difference between analog and digital. Again, all the amplitude and phase variation is done at the digital level. Here all the amplitude and phase variation is done at the analog. Here all the variation is done at the digital. Again, another one is here all the beamforming operation is done at the RF level, but here all the beamforming operation is done at the digital domain. Okay, so these are all the differences between analog beamforming and digital beamforming. So based on the requirement, we can go with either analog or digital. If you are using analog, you need more number of phase shifters, but digital, only the antenna array is needed. So this is the difference between analog and digital beamforming. So what about the next category? So next category is conventional array. So beamforming can be done either using conventional array or using adaptive array. So what is the difference between these two? So in the conventional array, there is a fixed predefined antenna patterns are there. Okay. So for example, so these are all the beams produced by the conventional antenna array. So I have used some 5 antenna elements at the transmitter side. Every antenna element produces some directional pattern. So I can get some 5 beams at the transmitter side. Okay. So these are all the fixed predefined pattern. What do you mean by fixed predefined pattern? This radiation pattern is always towards this direction only. This pattern is towards this direction only. We cannot have any radiation pattern in this direction. Okay. So this radiation pattern towards downward. Okay. So these are all the fixed radiation pattern. This is about the conventional array. Then every antenna element weight is fixed one. So that it is called fixed conventional array. Clear? Suppose if any of the user is in this place. Suppose if the user is here. Okay. If the mobile user is here, no problem. Which radiation pattern is formed towards the mobile user? This radiation pattern. Because if the mobile user is towards this radiation pattern, so this beam is focused towards the mobile user. Suppose if the mobile user is moving towards this direction, So at this point, at this time, the mobile user is here. So in this place, there is no beam. Okay. So the nearest beam is assigned to the mobile user. Which one is the nearest beam? So the second, this is beam 1, this is beam 2. So beam 2 is assigned to mobile user. So this is the principle of conventional array-based beamforming technique. So conventional array-based beamforming technique, what about the concept? Here there is a fixed predefined patterns are there. So any one of the pattern is assigned to the mobile user based on its location. Okay, suppose if the mobile user is directly towards the location, directly towards the beam, the corresponding beam is allocated. Suppose if the mobile user is in between two beams, which beam is closer to the mobile user, that beam is assigned to the mobile. Okay, so here sometimes the mobile user can get good signal strength from transmitter. Okay, sometimes for this situation, this mobile user get good signal strength from the transmitter. But this, suppose if the mobile is moved here, he may get little bit less signal strength from the transmitter because he is in between two beams. So this is about the problem of conventional array-based beamforming. Here everything is manually controlled. Clear? So the next one is the adaptive array. It's a adaptive array. It consists of infinite number of beams. Okay? There is no predefined pattern. Infinite number of beams are there. So using some signal processing, so first the location of the target is identified. So based on the location, the beam is formed towards the location of the target. So that is about adaptive array. Okay. So it needs more computational complexity. Okay, compared to conventional array. So this is the difference between conventional array based and adaptive array based. So here everything is automatically happened. Suppose if the mobile, there is no fixed pattern. So based on the location of the user, the beam is formed. Clear? So the beam is formed towards the direction of the user. So what are the advantages of beamforming? So what we are doing in beamforming, we are making the direct link between transmitter and receiver. So because of this direct link, what about the communication? The communication is very fast and the communication is very strong and it supports some high capacity. So these are all some of the advantages of beamforming. Okay. So high, faster communication, then stronger communication and reliable communication between transmitter and receiver. So these are all the advantages of beamforming. So what about the next category? The next category of beamforming is transmitter and receiver beamforming. Transmitter beamforming. So there are two elements in beamforming. One is the beamformer and another one is the beamforming. What are the two elements in beamforming? One is the beamformer and another one is the beamforming. Beamformer is the person to generate the beam or to form the beam. Who is going to form the beam? He is called as beamformer. Okay. So who is going to get the benefit? That is, he is called beamforming. Normally the transmitter is called beamformer and the mobile user, the client, okay, the client is called the beamforming. Clear? So in transmitter beamforming, we are using multiple or the array of antenna elements we are using at the transmitter side. The beam is formed at the transmitter. Okay, so that beam is directed towards the receiver. So that is the principle of transmitter beamforming. So the block diagram of transmitter beamforming is So beamformer, this is about beamforming. So transmitter, this is about the channel, and this is about the receiver. Okay. So what we are doing in transmitter beamforming, so first the transmitter transmits some training sequence. Okay. So that training sequence is received by the receiver. Now the receiver calculates some channel state information, CSI. Already we have discussed in the last class, CSI. What do you mean by CSI? Channel state information. So what is the use of channel state information? That information gives the status of the channel. Suppose if the channel may be good channel, the channel characteristics may be varying. So that information is delivered by channel state information. Okay. So what we are doing, transmitter transmits some training sequence. So using the training sequence, the receiver calculates the channel state information. Now that channel state information is fed back to the transmitter. Using that channel state information, the transmitter calculates the steering matrix. Now this steering matrix is used by the transmitter to rotate its beam. Okay. So what is the use of this matrix? So in adaptive beamforming, the mobile is moving from one place to other place. So the location of the mobile should be periodically monitored, and based on the location, the beam is formed. So that is the principle of adaptive. So the steering matrix or rotating matrix should be periodically calculated. So how they are calculating this matrix? Based on the channel state information. Okay, so based on the channel condition, this matrix is calculated. Now this matrix is given to the transmitter. Now the transmitter can transmit the information using this matrix. Okay, so what information it can collect from this matrix? At which direction the transmitter to transmit it information. Okay, so that is decided by the amplitude and phase of the transmitted signal. Okay, so based on the different phase angle, the antenna beam can be tilted. Okay, so that is the principle of transmitter beamforming. So transmitter to channel, then receiver, we are calculating the channel state information. That information is passed to the transmitter. Now the transmitter find out the matrix, steering matrix. Using this matrix, the transmitter can rotate its beam. Okay, so that is the principle of transmitter beamforming. So normally we are using array of antenna elements at the transmitter. If it is a transmitter beamforming, we have to use array of antenna elements at the transmitter. If it is a receiver beamforming, we have to use the array of antenna elements at the receiver. Okay. So all the transmitter beamforming means all the antenna elements radiation patterns are combined and it produces a high gain pattern in one direction. So this is about the transmitter beamforming. Then what about the receiver beamforming? It uses multiple antennas. All the antenna signals are combined. Then it forms its beam towards the direction of this transmitted signal. So this is about the transmitter beamforming and this is about the receiver beamforming. Okay, at which direction the transmitted beam is coming, towards that direction the receiver will produce its beam. Okay, so this is about the transmitter and receiver beamforming. So how to implement transmitter beamforming? So we are using two techniques to implement transmitter beamforming. One is the implicit beamforming and another one is the explicit beamforming. What are the two techniques we are using? Implicit and explicit. So what is the difference between implicit and explicit? In implicit beamforming, the transmitter transmits some training sequence, then it gives some sound, it expects some sounding packet from receiver. Okay, so what about the sounding packet? So the sounding packet doesn't give the full CSI channel state information. It doesn't have any data. Some partial information about the channel is available in the sounding packet. So after receiving the training sequence, so that partial information about the channel is passed to the transmitter. Okay, now the transmitter calculates the channel state information, that is the beamformer is the transmitter. Beamformer calculates the channel state information, then beamformer calculates the steering matrix, then using that steering matrix the transmitter forms a beam. That is the principle of implicit beamforming. What is the principle of implicit beamforming? Transmitter transmit the training sequence to receiver. Now the receiver sends some sounding package to transmitter. So it carries some partial information about the channel. So using that information, the transmitter or beamformer calculates the steering matrix. Okay, so using this matrix, now the transmitter forms the beam. So this is about the implicit. Okay, then what about the explicit beamforming? So here implicit more burden on transmitter side. What about the explicit beamforming? The same principle. The transmitter transmit the training sequence to receiver. Now the receiver calculates the channel state information. Okay, so now after calculating the channel state information, it is fed back to the transmitter. Now the transmitter calculates the steering matrix. Okay, so using the steering matrix, the transmitter rotate its beam. So this is the principle of explicit beamforming. So explicit beamforming, the matrix is calculated by beamforming. Implicit beamforming, the matrix is calculated by beamformer. So this is the difference between implicit and explicit beamforming. Okay, so that's all about beamforming. So what are the things we have discussed today? Beamforming. Okay, what is the role of beamforming in smart antenna? Then types of beamforming. What are the different types we have discussed? Analog and digital beamforming. Okay, then transmitter and receiver beamforming. Then how do you implement transmit beamforming using explicit and implicit techniques? Okay, then another one we have discussed, that is the conventional beamforming as well as adaptive beamforming. Okay, so what are the advantages of beamforming? Why we have to use beamforming in smart antenna? To get a direct connection between transmitter and receiver and to improve the link quality, that is the reliability of the link, and to produce the strong as well as faster communication between transmitter and receiver. So that is the basic principle of beamforming. Okay, so that's all about today's topic. So take down some of the objective type questions. Beamforming, first question is, beamforming is applied at only transmitter. Okay, this is the first question. Is it true or false? Okay, A true, B false. Okay, first question is, beamforming is applied only at transmitter. So next question is, beamforming is dash. So the options are spatial multiplexing, spatial diversity, C, spatial filtering. So this is about the second question. What is used to calculate steering matrix? Third question. So to calculate the steering matrix, which information we need at the transmitter side? So one is the channel state information, and second one is the fading effect, and third one is the roll-off factor. So which information you need at the transmitter side? So these three things you submit as assignment. What are the questions? Beam forming is applied only at a transmitter. Is it true or false? Then second question is beam forming is dash. It's a spatial multiplexing, spatial diversity, or spatial filtering. What is used to calculate steering matrix? One is the CSI channel state information, second one is the fading effect, and third one is the roll-off factor. So that's all about the assignment. Okay. So next class we will discuss about some problems from diversity. Okay, thank you.
சரி அப்புறம் பார்த்துக்கலாம். ஏன் இல்லை டைம் நேற்று ஆனால் இந்த டைம் தான் செந்திலோட தாங்க. Good morning. Let us look at electrical safety topic today.